All right, I'm gonna attempt to see if I could show something that happens. Okay, so there's my screen right there, but I'm also looking at the screen right here. So if we look right about here at this part, and if you look all the way up there, the maximum temperature is about 99 degrees, and I'm shooting right around in this area right there. 98, 97. Now if I come over here, up here to the top, and I shoot there, let me get this thing out of the way. This is just in the way. I'm about 115 max. If you look up there at the top, 111, 115, center, 100, because that's where the refrigerant enters, right there. Right about there. That's the refrigerant entrance. So we got about 113 to 98 degrees. Our mid right there. But if I come way down here, you see it drop to a max of 94, around 80. Now there's a problem. The radiator is right behind these fins, and you see these fins? You can see through these fins with your eyes. If there's a light back there, you can see the radiator. When there's hot coolant, the radiant rays, like protons of light, stream through the openings of the fins and actually will throw your measurements off on your infrared thermometer or your infrared camera. And you don't know that, but it happens. And you gotta be really careful when you have a hot object and you're clear, you're see-through, and you have a hotter object than the object you wanna see, and you have these fins with holes in it, and you're right here, you are actually seeing part of the heat that is radiating out through the fins, giving you a little bit of a false sense of temperature. If I could get over here, you can see right where there's the line, and you can see I'm looking at the line right there, and you can see where the hot refrigerant's going in. And here's the subcooling right there. There's that line right there. That's what it looks like. We're looking at that line, that bulb right there. So if you come down here and you look up, you see where it looks a little bit more light color up there? Because that's not the subcooling. That's hot gas going across the top. All that is hot gas. Now as I come down here below, you see that shadow? Look down. You see that shadow in the mirror, in the camera? That's your subcooling area. That's liquid refrigerant right there. So if you look, count these fins. 1, 2, 3, 4, 5, 6, 7, 8. The 8th fin. If you look at that shadow and you count the fins, you'll see that it, or not fins, tubes. If you count the tubes, you'll see that it's 8 tubes. And if you come right over here, where the hell is it? Do you see that little piece of metal right there where that little thing is? That's a block. Up here is vapor hot refrigerant. Down here is liquid refrigerant. Because this vapor hot refrigerant is entering the receiver dryer and filling it up, but the liquid is falling to the bottom, and there's a little hole right in here, and this is filling up with liquid refrigerant, and this is your subcooling, these last 8 rows. And that is why, where did I put the camera? That is why when you break out the camera, you see that kind of shaded looking area at the bottom, but when you go up and you look up, you see it's brighter and hotter, and you can actually measure the temperature. Up here it's all hot, and it's hot gas. But once it comes out of the bottom, it starts subcooling the liquid, and you get that darker shadow coming out the bottom, and the temperature drops really fast from that corner to that corner because it's subcooling the liquid. Sometimes when you get a condenser and there is a burnout, it'll plug some of these tubes. It might plug several layers of tubes where the debris will come out, it'll fall to the bottom, and it might block 4, 5, or 6 tubes. And when you're looking at it, you'll see this dark shadow going right through the middle where there's no heat. And if you have one of the little wire thermocouples and you stick the little wire in the fins and you touch a tube, you could count the tubes and you say like 110 degrees, 110 degrees, 110, and then all of a sudden you get 60 degrees, 60 degrees. Those will be your block passages from having compressor debris inside the system. And so we're getting a hot head up there. And you can see the cold suction line. You see how black it is? That's our suction line right there. You can't take the temperature of it. Do not rely on your thermal camera by pointing it at something like that. There's so much radiant heat coming off of here that you cannot rely on it as a very accurate temperature, usually. All right, so that's all I want to see you to see is being able to see the subcooling, and you could see me how I'm hot. And if I point down here, you can see in the camera where I'm at. All right, but remember, when you're using a thermal camera or thermometer, there are times where you could be pointing right at it, and if you have a 190 degree radiator, you will get some false readings coming directly through the fins right into the lens of your thermal camera. So be careful what you try to measure, especially off you have to set your emissivity when you are doing something like bright shiny aluminum. Flat black, it does flat black really good. It's really fast and accurate on the flat black. So there's the flat black. You can see where my finger touched. And then we come over here to the bright aluminum, and it does quite a little bit of a spread there. See, I'm going to put my finger right here. See if we got some heat there. And there's my finger spot right there. All right, guys, I'll see ya.